Hello everyone. Today I am going to explain you about the prediction of house price using the machine learning project. So here the main aim to discuss with this project is here we are going to predict the house prices in the market. Here we are taking two areas, that is Rajajinagar and first block Jainagar. So in these two areas we have got some data set which we are predicting using that. So here we are using the linear regression model, random forest, navy biased and decision tree algorithms to predict the model. For this we are for training purpose we are using this four algorithms. So for testing purpose we are using the linear regression algorithm to predict the values of the house price in the data set. So this is what the main aim of this project. So let's we see about the data set. So this is what the data set we have: area type, availability, location, size, society, total square feet, and how many BHK which we have, and balconies, and price of that square feet. You using the location, we are predicting the price of that for the square feet. So this is what the data set you have. So next we are going for a code. First we will go through about the training code. So this is what the training code we have. Here we are loading the data set, and after that we are plotting the plot for price column, means price field in the data set. Afterwards we are displaying the info of the data set, which are the fields we have, data set we have, so that are displayed. After this we are splitting x and y. So x will drop the column, that is size. So y will take the product value. So here x train and x test, y train and y train. We are splitting that into train and test of x and y. So for the that values will be printed here. Afterwards logistic regression we are using here. So using the logistic regression we are getting the accuracy, sensitivity, precision value, f1 score, and recall score. For logistic regression is nothing but the linear regression model. Next model is about the random forest. Same what we have did for logistic regression, same will be done for random forest also. Here you'll get an accuracy, precision, sensitivity, f1, and recall score. Next is decision tree. So decision tree will also take same, like its accuracy, sensitivity, precision, and F1 and recall score. So last is navy bias. Navy bias will also print the accuracy, sensitivity, precision, F1, and recall score. After all this, we will get the accuracy plot, bar plot for all the algorithms, like logistic regression, random forest, decision tree, and navy biased. So this can be, you can see the output. Just save your file and run your module. So this is what the data of info of the data. So here you have a 9 attributes or 9 fields. So 9 fields are there. So count values, not null values, and the data type of that column will be included here. So this is what the info of your data set. So after this, you'll get a of graph of price which you have in the data set. So, yeah, for that we are getting the graph. So after this, you'll get the correlation graph for each and every columns which are there in your data set, like price, balcony, and the PHKs. So using that, we are getting this. I already told you I already told you about this. See, X train, X train, Y train, and Y test. All the values will be printed here. Afterwards, you'll get the linear regression model accuracy, decision, sensitivity, precision, F1, and recall score. After all this, you'll get a convex matrix of that algorithm. Same for random forest and decision tree and naive bias. After all this, you'll get a accuracy plot. Here, logistic regression has got 96 percentage of accuracy. So it will show 96. So this is what your accuracy plotting will be for training. So now we will go for a testing code. So this is what the testing code you have here. Here we are predicting the model using the PHKs, and the count versus price prediction will be done for per square feet, which we have sent the number of PHKs which we have, so that will be predicted using the graphical representation method. So same way, we just want to save and run the module. So here also I'll get the info. After info, we are getting this. You're getting this plot. This plot is related to both. This is first plot which you are getting is related for location Rajajinagar. In the Rajajinagar location, how many prices per square feet it has, and how many BHKs it has. So you can see here, blue dot will represent the 2 BHK, and plus in the green mark will represent the 3 BHK in this plot. So next plot is also a same. Here it will predict about the square feet and the area of the plot. So this plot will represent same, but here the area will change. Here we will take a first block Jainagar or phase. First phase Jainagar. And that how many we have 2 BHKs and 3 BHKs will be predicted. So this count will be predict. This is versus count versus price prediction of square feet. So in all areas, in all locations, how many prices are there per square feet will be predicted. And this is also number of bedrooms which we have in the location. In locations we have many locations like electronic cities, Jayanagar and JP Nagar, or in all those locations, how many of them has the, so here you can see 2 BHK is more compared to 4 BHK or 6 BHK or 8 BHK. So this is what the plotting of reduction of this BHK. So next plot. So this is what we have in the production and testing code. Yeah. So now we will go for house price prediction. Just run the module. Run a module. So give the square. Okay. How many bedrooms it contains? Storerooms. Storerooms like two. Just predict it. So it's for 6,413 rupees is for this rent. So next one we will take it. Another one example. Just run a module. So area square foot will be square feet is that much. So how many storerooms you have, you can specify it. It is 77,599 is the rent value for this house, particular house. So next, another one example we will see. Just run the module. So it will be the square feet. Square feet. And just fine. It is 5,120. Sorry, 142 rupees for this house. So like this, we can predict the house rent price. You see?